Hi everyone, hope you're doing great. Welcome back to another video in our manual testing series. In today's session, we are going to talk about test design technique, one of the most fundamental topics in software testing. But before we jump into these techniques, let us take a step back and try to understand what test case actually is and what makes up the basic structure of the test case. A test case is a set of actions or a conditions written to verify whether a specific feature or a functionality of an application or a product is working as expected. It is like a detailed instruction sheet for a tester, telling them what to test, how to test it, and what to expect, and how to decide if the test case is passed or failed. A very well written test case follows a clear structure. The common component of the test case includes a test case ID and unique identifier to identify the test case. Test case description, it is a brief summary about what we are going to test or what is the goal of testing or what is the intention of this testing. Next one is precondition, any step or condition that must be met before executing a test. For example, if you want to log in into an application, first you'll have to open an application, right? You have to open an URL in a browser. That is called as a precondition. Test steps, a detailed sequence of action that we are going to perform. Okay, in case of a login, you'll have to enter the username, password, and then click on a button, login button, to that will take you into a login successful page. Okay, these are written as part of the test steps. Now the expected result, what do you expect the application to do after performing the steps? For example, in case of login, as soon as you enter username, password, and click on a login button, you will be taken successfully into a next page where you can see the application dashboard and etc. That is called as an expected result. Actual result, what the application actually does when you execute the test steps. Okay, then the status, whether the test case is passed or failed based on the comparison between the expected result and the actual result. These are the key components that a good test case should have. I have given here a couple of examples. The first one is to verify the login functionality with the valid credential. Okay, you can write it as test case ID TC001. Then you have to write a description telling that verify the user is able to log in successfully with the valid credential. Mainly a little bit of summary what you are going to test. A precondition is user must have a valid username and password, as well as you can also add one of the precondition as the application is already ready, right? It is open, right? So the steps, open the login page, enter a valid username and password, then click on the login button. The expected result is the user should be redirected into a dashboard page, and the actual result is to be filled after the execution, and while the status will be pass or fail based on the comparison between the actual result and the expected result. Second example here is testing a coffee vending machine. You must write a test case like this. Insert a coin, select the cappuccino from the machine and press start. Expect a cup of cappuccino to be dispensed. Okay. If the machine gives you a cappuccino as expected, then the test case is passes, and if it gives a black coffee or some other product, then the test case fails. So using these techniques, you can write a very detailed test case. Write a scenario like I'm going to verify the functionality of coffee vending machine. So you can write test case ID as TC002. You can give a brief description that I am going to test the functionality of coffee vending machine. The precondition is the machine is on and it already had the have the enough milk and the coffee beans to make a cappuccino, right? Then the detailed step, right? You have to insert a coin, select a cappuccino and press start. That is the sequence of steps that you are going to perform. That will come here. then the expected result is the machine dispenses the cappuccino. Okay, actual result is you have to write it after the execution. Then the status is based on the comparison between expected result and the actual result. That is exactly how test cases work in software testing. They help us to verify that the system behaves as expected under the defined condition. In short, test cases are the foundation of testing process. They ensure consistency, repeatability, and traceability in how we verify the software functionality. Now that we understand what test case is and how it is structured, let us move one step further. Now, let us try to understand the different kind of techniques that are used to derive the test cases. This is called as a test case design techniques. The techniques we are going to discuss next will help us design effective test cases, not just random ones, but those that are well thought out, cover maximum functionality, and detect defects early in the process. A test design technique is a systematic method used to identify and create effective test cases based on software's requirements, functionality, and structure. These techniques help the testers to determine what to test and how much testing is enough by selecting a representative test condition that maximize the coverage while minimizing the number of test cases. In simple terms, test case design is a technique help ensure that our testing is both effective and efficient, enabling us to detect the defects early without having to test each and every possible input or scenarios. In a real world projects, it is not practical to test every possible input scenarios. That is where test design techniques comes in place. These techniques help us to create a smaller optimized set of test cases that still provide a strong coverage of the application behavior. In short, they help us to test smartly, not exhaustively, reducing the effort while increasing the chances of critical bugs in the earlier software development life cycle. So, it helps in catching the critical bugs. For example, in an application, there is an edit box which takes an integer up to a length from 1 to 32 characters. So is it possible to test the input box with all the combinations? No, that is not possible, which will be very exhaustive. So in such cases, these test design techniques help us to design the test cases effectively. So let us explore some of the most commonly used test design techniques and understand how each one helps in improving the test effectiveness. Some of the important test design techniques are boundary value analysis, equivalence partitioning, decision table testing, state transitioning, exploratory testing, techniques and heuristics, use case based testing, orthogonal array testing, and risk based testing. Boundary value analysis, or in short BVA, is a black box design technique that focuses on identifying the errors at edges or boundaries of the input domain rather than within the range itself. The idea here is that defects are more likely to occur at the boundary values than in the middle of the valid ranges due to off by one errors, incorrect operators, or input validation issues. The goal of the testing is to ensure that system handles the boundary values correctly or not, to uncover the defects that occurs at extreme ends of the input ranges, not just inside and outside the boundaries, to reduce the number of test cases while maximizing the defect detection efficiency. Let us take an example a scenario where a streaming service allows the user registration only if the user age is between 18 and 60 years. So what are the business rules? If the age is less than 18, registration is not possible. If the age is between 18 and 60, registration is allowed. If the age is greater than 60, registration is not possible. In a normal testing, we can give the application any values from 0 to infinity, let us say, right? So because this is to play with the number, right? So, but can we test them? No, it will be very exhaustive testing. To overcome that, we will have to apply the boundary value analysis technique here. To apply the boundary value analysis technique for this particular scenario, you will have to first identify the input field. Okay, so where the business rule is going to be applied. So in this case, the input field is the age. Second thing is to identify the valid range. What is the valid range here? 18 to 60. The third one is the lower boundary, which is 18 here, and the fourth one is the upper boundary, which is 60 here, using which you can now develop or derive the test cases. So the step 1 is identifying the input range and the boundaries. That is done. Okay. Now the step 2 is basically derive the boundary values. So we have the two boundaries, upper boundary and the lower boundary. So we will have to derive the test cases something like this. Okay. So we have to test the lower boundary, the -1, and the lower boundary +1. That will cover the entire lower boundary test cases. And here the upper boundary is 60. So we'll have to do upper boundary -1, that is 59, and upper boundary +1, 61. So the total, the values that you want to test here is 17, 18, 19 for the lower boundary, and 59, 60, 61 is for the upper boundary. So, okay, using this we can basically derive the test cases. That is the step number 3. Okay, so if you see the test case 1, I have given the input age as 17. So the application will not allow the registration. So this is reject. Okay, because it is at the lower boundary, it is less than 18. For an 18, the registration is accepted. For 19, again the registration is accepted. For the higher boundary, the 59, again the registration is accepted because the age is less than 60. For the 60, it is exactly at 60, so it is accepted. For 61, age of 61, the application is rejected because registration is rejected because it is above the upper boundary. So you can have the valid 6 test cases to test these conditions, okay, by using the boundary value analysis. Without boundary value analysis, you will without any technique, you will test with multiple inputs, right? And it is not guaranteed that these test cases, the multiple test cases, will basically leads you an defect or not. But using a boundary value analysis, you have reduced the test cases, and this testing is also very, very effective. There is a guarantee that you will catch the defect in case the developer has not written the code properly. This technique basically helps to test where the validation logic is mostly like to fail, such as developer is using greater than instead of greater than or equals to, forgetting inclusivity and exclusivities in boundaries, failing to handle the edge input types like min max for the integer values. Okay, these are all the cases where the developers can make a mistake. So this technique will really helps you in catching these kind of critical errors. The next technique is equivalence partitioning. Equivalence partitioning, short form EP, is a black box test design technique that divides the input data of a software system into equivalent classes or the partitions. Each partition represents a set of valid input conditions that are expected to be treated in a same way by the system or an application. The idea is very simple. If one value in a partition works correctly, then the rest are assumed to be behave in a same way. The goal of equivalence partitioning is to reduce the total number of test cases without losing the coverage. To ensure each logical input, valid or invalid, is tested at least once. Okay, at least once it will be tested. To detect the defects caused by improper handling of the input conditions or the data ranges. Let us consider a real world example where an online form is performing a wage validation, okay, age field validation. The scenario is something like this. A registration form accepts user's age between 18 to 60 inclusive. Okay. So what are the conditions that we have? If age is less than 18, it will give 2 youngs to register. 2 youngs to register. If the age is between 18 to 60, it is a valid registration. If the age is greater than 60, it says that not eligible due to age restriction. Now let us see how do we basically create a test cases using the equivalence partitioning. Okay, the first step is to identify the input condition. What is the input condition here? The age entered in the form. Okay, the age can take all the possible integer values, right? Now the step number 2 is dividing the input into the different partitioning. So we will divide all the possible into the equivalence classes. Okay, so how do we do this? This is how basically we are going to do this. So you have the partition type as an invalid class 1. So valid class and invalid class 2. These are the 3 different partitions. Okay. For all the ages which is less than 18, it will go to the invalid class 1 partition. The age group between 18 and 60 will go to the valid class partition. Okay, and the age greater than 60 will go to invalid class 2 partition. Okay, so we have the 3 partitions based on the 3 conditions, right? So we had a condition like if age is less than 18, then the user will not be registered. If age is between 18 to 16, then the user will be registered. If the age is greater than 60, the user will not be registered. So we have the 3 different partitions here. Okay, these are partitions I have named here as invalid class 1, valid class and invalid class 2, and the range that will be a part of this partition is written here. Okay, so the expected result is here it is 2 young to register, here it is accepted, and he is not eligible for the registration if the age is greater than 60. Okay, now the next thing is to identify or select a representative value for each of these partitions. Okay, for example, for the invalid class 1, I can select only one value. That is because for any value that is in the range of invalid class 1, the application is going to behave same, right? For example, if you put 10 or 15, it doesn't matter. Application will always give an error like 2n, right? You can put 0, you can put 5, you can put 10, you can put 15, you can put 17. The application is going to behave in a same fashion. So I will select one value from this particular class. Similarly, I will select one value from this particular class, and I will also select one value from the invalid class 2. So with the 3 values, you can basically test the entire range, right? Entire range validation. Okay, that is how basically equivalence partitioning works, and it basically divides the input range into the different equivalence classes, and then we select one value and test that particular equivalence classes. Okay, this is a very effective technique is going to save a lot of time and also reduce the exhaustive testing. So for example, so the test cases will be like, for example, something like this. Okay. Yeah, the test cases will be like this. Class, for example, here I will invalid class 1. I will take a value as 10, then I should get an error as too young. I will, for a valid class 1, I will put a value as 13. Then the application should accept the application. For the invalid class 2, I will put a value as 70. Then it will come, application will give an error as not eligible. So with using the three values, you can basically test the entire condition. Some of the real world examples where we use equivalence partitioning are banking, the input ranges for withdrawal limits, loan interest rates, insurance, valid versus invalid policy numbers, claim amount thresholds, e-commerce, the price ranges for the discounts, shipping eligibility by region, healthcare, age-based medication dosage or rules, education, the grade classification by score A, B, C, D, E, F, etc. You can think of equivalence partitioning is like checking a samples from a batch of products. If one product from a well-controlled batch works fine, then you can assume that others also works fine. This will basically saving time while maintaining the confidence in quality. I can give you one bonus tip here. It is always good to combine the boundary value analysis with equivalence partitioning. Often, the equivalence partitioning is always used alongside of boundary value analysis. Equivalence partitioning ensures each partition is covered, whereas boundary value analysis ensures boundary points of a partitions are also tested. Together, they form a strong, minimal, and effective test suite. Decision table testing. Decision table testing is a black box testing technique that is used to model and test complex business rules that involve multiple conditions and corresponding actions. Decision table is very useful in case of an application where there are a lot of business rules that involves multiple conditions and the corresponding actions. Each combination of input condition, the true or false, yes or no values, etc., determines a specific action or an output. Decision table helps the tester to ensure all the possible combinations of inputs are considered and redundant or impossible combinations are eliminated logically. The goal of the decision table testing is to ensure a complete logical coverage of all possible input combination. To identify missing or conflicting rules in a business logic early in the development life cycle. To simplify complex decision making logic into a structured testable format. To reduce redundant test cases through a rule based optimization. Let us try to design a test case using a decision table for a following scenario. The scenario is an online retail website gives a discount based on the three conditions. What are the conditions? First one, customer is a registered member because the condition is yes or no here. Okay. Second one is the order value should be greater than $100. Third one is a coupon code is applied or not. The business rules are if the customer is a member and the order is greater than $100, it is a 10% discount. If a coupon is applied, then additionally we have the 5% of discount. If neither condition is true, then no discount is applied. In case of decision table testing, the first step is to identify the conditions and actions. What are the conditions here and what are their actions? Let us try to list them down. The conditions are the condition 1, you should be a registered member. What is the possible values? Yes or no. The condition 2 is order should be greater than or equals to $100. The possible values are yes or no. The condition 3 is the coupon is applied or not. The possible values are yes or no. What is the action from these conditions? To apply the discounts. So there is a mathematical formula involved here. If there are 3 conditions, then we will have the 8 different combinations. That is always be using a formula. It is 2 to the power n, where n is the number of conditions. If the number of condition is 2, then the value is 4. If the number of condition is 3, then the value is 8. If the number of conditions are 4, then the value is 16. Okay, here we have a number of conditions are like 3, right? If here we have number of conditions are 3, that is C1, C2, C3. So we are going to have the 8 different combinations. So if you have studied a Boolean table, like for the 3 conditions, it is like it will start with the value 0, 0, 0, right? 0 start with C1, C2. You can put a table with C1, C2, C3 as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, and it goes up to the 1, 1, 1. That is the last value. It starts with 0 and ends with at 7. It is using the binary combinations, right? So it's called as a truth table. So if you know how to write a truth table, this is very helpful in writing the different combinations for the decision table. Now let us list out the different combinations. The different combinations are here, as I told. If 0, 0, n is, take it as a 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and it goes like this. Okay, so where y is a 1 and n is 0. Okay, so along with this, so there is also a condition. If you see in our problem, right? So we had a business rule, something like this, right? So we had a business rule, something like this. Let us write it down. Okay, if the customer is a member and the order is greater than or equal to $100, then 10% discount. If the coupon is applied, then you have a 5%. If none of these conditions are there, then no discount. If coupon is applied and then if this is also satisfied, then you have 10 plus 5, total 15% of discount. Okay, let us start with here all the values are no, no, no. That means he is not a customer. The first case itself is not a customer. Then we don't have any discount, so 0 discount. Okay, now he is not a customer, and then his value is he is not purchased anything above $100, but he has applied a coupon, so he is eligible for 5% of discount as per this particular business rule. Okay, next one is if he is not a customer, then he has purchased. If he is not a customer but he has purchased the value worth of $100, but he has not applied any of the coupon, then there is no discount. Okay, and then he is a customer. He is not a customer, but he has purchased above $100 and he has applied a coupon, then will get a 5% of discount. Okay, so then he is a customer or he is a member, but he has not purchased anything, not applied a coupon, then there is no discount. So he is a member, he has not purchased anything, but he applied a coupon, then he will get a 5% of discount. Then he is a member, then he purchased something and he has not applied any coupon, then he will get a 10% of discount. And then the final one, he is a member, then he is a member, he has purchased greater than $100 and is also applied a coupon, then he is eligible for 15%. These are the different combinations. But if you see if you look at these combinations, certain test cases are not valid. Okay, for example, uh, for example, so he is not purchased anything, but he is applying a coupon. Is it valid a test case? So if he has not purchased anything, why would he go and apply the coupon, right? So that is not a valid condition. So there are some invalid conditions here as well. So the fourth step, the next step that lies in decision table is to take out the combinations that are not relevant. Okay, let us strike out these combinations. Now let us go and identify the valid and invalid conditions. Okay, one of the condition here is also, if he is a guest member, that means he is not a member, then he is not eligible to put any of the coupons, right? So if he is a member, then only he can apply the coupon. Okay, so if you take that situation, then this will basically go off, right? Yeah, this will not be a valid input combination. Similarly, the test case 4 here. He is not a member, then he cannot apply the coupon. So this will also will go into an invalid combination. Okay. Next one is, he is not a member, he can purchase a good. Yes. He is the member, he is not purchased a good. Okay. Then how can he apply the coupon? It is not possible to apply the coupon as well. Okay. So this is also gone. So let us go back and revisit again. So this can be a good combination. He is not a member, he is not purchasing, he is not applying a coupon, he just visits shop and goes off. Then he is not a member, but still he can, as a guest member, can also purchase something, right? I'm not a member, I can go to a shop and purchase something. This is a valid combination. Then here I am a member, then I can I am a member, let us think that I am a member, I can go to a shop and I come out of a shop without purchasing anything. That is also possible. Now I am a member, then I can purchase. Yes, I can also not apply the coupon. That is also possible. And I can be a member, I can also purchase more greater than $100, and I can also apply the coupon. So the valid test cases here are TC1, TC3, TC5, TC7 and TC8. So out of the 8 combination, we knocked off the 3 combination which are invalid, and only we are testing with the 5 combination which are valid. Using this technique, basically you can optimize the combinations. In case your business rules are very complex, you can apply this technique to reduce the number of test cases, and we can only keep the valid combinations. We can remove the invalid combinations. Think of decisioning table testing is like a restaurant recipe chart. Each dish, which is an action, depend upon a combination of ingredients which are conditions. You don't cook every possible mix, only the valid and meaningful ones that are result in a good dishes or a real dishes. State transition based testing, or STT, is a black box test design technique used to test different states of a system and how it transitions from one state to another state based on specific events of inputs. A state represents a particular condition or a situation of a system at a given time. A transition is a movement from one state to another state triggered by an event or an action. The goal of a state transition testing is to ensure that system behaves correctly for every valid state change. To verify invalid or forbidden transitions are handled properly. To validate that the system remembers its current state and responds accordingly. To test the workflow dependent logic where outputs depend on a period inputs and actions. One of the scenarios that we can use is the ATM withdrawal. An ATM system allows the following operation based on the card and a pin. The first one is a system. The ATM machine is in idle state, and you insert a card. The system asks for the pin. Then if you enter a correct pin, the system moves to the transaction selection state. If you enter a wrong pin 3 times, then your card will be blocked. And if you cancel the transaction or eject the card, it comes back into the ideal state. These are the different states that ATM machine can go into. Okay, now you have to write a test cases to validate the ATM machine based on the state transition technique. The first step here is to identify the states and the transitions. Okay, in this case we can have these states and transitions. The state S1 where the ATM machine was idle and it is waiting for a card. Okay, then you inserted a card. So the now the ATM machine is basically waiting for you to authenticate it by putting a valid pin. So you authenticated it with the current pin is entered, then the user can select the amount of money, then the transaction will happen. Okay, if he enters a wrong pin, then it goes to a state blocked. The card is blocked after the 3 invalid pin attempts. These are the different types of states that we have. Now we have to identify the set of events that can cause these states and their transitions. Okay, so we can have these many events. First one is event 1 where the machine is in an idle state and you insert the card. So current state of the machine is idle. When you insert a card, the next state will be it will go into a card inserted state, and the expected output it displays you to it reads the card and asks you to enter a pin. The event enter a current pin. Okay, now what is the current state? The card is inserted. Now you are entering the pin, then you will get an access, then you can withdraw the money. So if you enter a wrong pin for first, second time, the card inserted, the current state is card inserted, next state will also be in a card inserted, then it will give a prompt like incorrect pin, try again for the first wrong and the second wrong. But if you enter the pin for a third time wrong, then you will be in a current state called as a card inserted. Your next state will be card blocked. Okay, the expected outcome is card is blocked. Okay, now you cancel the event or eject the card. The current state is card is inserted. Now you are cancelling the transaction or taking the card out. Then the machine will go into idle system, returns to the home screen. So if you enter a correct pin, okay, so the current state is authenticated, then you try to withdraw an amount, then it goes to the event here is complete the transaction, then the current state is authenticated. When you take out your money and you reject a card, it again goes back into the idle state. It returns back to the home. This is the series of the events and the transitions. That is the second step to identify in case of state transition. Now the third step is to create a state transition table, which is a combination of this table with the state table. Okay, let us try to create that, and this will look something like this. You will have your current state, then you will have an event and where it goes to as a next state and what is expected outcome. So you are in an idle state. Okay, let us start with that, and you insert a card. Now it goes to the card inserted state and it asks for a pin. Now you are in a card inserted state and you enter a correct pin, then you will be authenticated. You will enter a correct pin, you will go into an authentication state and it will give you an access. Okay, so you can withdraw your money. So card is inserted, you enter a wrong pin for 2 times, then you will get into expected output telling that wrong pin, try again. Now the card is inserted, you again give a wrong pin, then your card will be blocked and expected output is blocked card. Your card is inserted, you try to cancel the transaction or reject the card, the machine comes to machine gives out you the card and it goes into an idle state. If you are authenticated, the current state is authenticated, then the event is complete the transaction, then you complete your withdrawal or any other transaction, then the machine comes back into the idle state. This is basically called as an state transition table. Okay, if you want to more clarity, you can basically also draw state transition diagram. Basically, what is an event, what is an current state, and what is an event, what will be the next state. You can basically represent in a diagrammatic format in a as an brainstorming kind of thing. Then based on that, you can basically derive this table. This table is a very important table to come out with the test cases. Now after this, the next step is to identify the valid and invalid transactions. Okay, so I will basically give you the valid and invalid transactions. So these are some of the valid and invalid transactions. The insert a card from an idle, the machine will go into move to the card inserted. Okay, this is the valid transaction, right? So when the machine is idle, you go and insert a card. That is the first step. Okay, and once you insert a card, then you are giving the pin. That is the second step. Can you give a pin without inserting a card? That will become an invalid transactions. Okay, can you withdraw a cash when your card is blocked? That is also not possible. Can you insert a card when the card is already inserted? Then it is also an invalid transaction. When one card is already inserted, you cannot insert the second card, which is also an invalid transaction. So you'll have to take out this transaction and you have to keep only the valid transaction in basically deriving the test cases. The final step is to come up with the test cases. So based on our state transition table, this particular table, right? So this particular table, we can have the below test cases. Okay, test case 1, where the state is idle, then you insert a card, then it asks for the pin. Okay, then the card is inserted, you give a correct pin, then it will give you it basically tells you that you are authenticated. If the card is inserted and you give a wrong pin, then it will be giving you a message, your pin is wrong, retry again. Your card is inserted, you give a wrong pin for a second time, then also you will get a message like error message, retry. If the card is inserted and if you give a pin wrong for a third time, then your card is blocked. If your card is inserted, you want to cancel an operations, you can take your card back and the machine will go into idle state. If you are in authentication, if you are in authenticated state and if you want to complete a transaction, then also the machine will come back to an idle state. Okay, now the machine is in idle state, and the machine is in idle state. You enter a pin that says that insert a card first. This is also one of the invalid combination. Okay, so you can basically design the 7 test cases for the ATM machine, the testing using the state transition technique. In a real world analogy for state transition technique is like imagining that you are checking into a hotel. Okay, so from where you start with no booking state, right? Then you book it, then the hotel will be reserved for you. After check-in, you will check into the hotel. After checkout, you will be coming out. You cannot check out before you check in, right? And also you cannot check in without a reservation. That is how the state transition testing ensures the valid flow of controls in a system. Next test technique is called as an use case based testing. Here basically you are deriving the test cases from an use case. Use case testing is a test design technique that derives the test cases from the use cases, which describe how the user interacts with the system to achieve a specific goal. Each use case represents a real world scenario which includes an actor who is an user or a system interacting with an application. The main flow, the normal process steps, the alternate flows, the optional or exceptional path, the preconditions and the post conditions. Use case testing ensures the system behaves correctly from end-to-end perspective, covering both functional and the exceptional or an error handling. The goal of use case testing is to validate that the system meets the business and user requirements correctly. Ensure end-to-end flow coverage for real scenarios. Detect issues related to integration and business logic. Verify the system's ability to handle alternate exceptional flows gracefully. Bridge the gap between requirement specification and test design, since use cases are often come from business analysis or from the business analysts or from the product owners. Let us consider an real world scenario, that is an online banking, like transferring the fund. The scenario is a banking system allows the users to transfer money between the accounts. The use case for transfer fund is as below. So here you have the use case name, which is transfer fund, and the primary actor here is a registered bank user. Okay, he is a registered bank user. He is the one who is basically initiating the transaction here. The precondition is that he should be a registered bank user. You should have the valid credentials, username and the password. He is already logged into his account. Now he is ready to transfer the money into his friend's account. The post condition is that the funds are transferred successfully and the transactions are recorded. So this is the main flow. The user navigates to the transfer fund page and he selects the recipient account. He enters the amount. System validates the balance. System executes the transfer. System shows a confirmation message. Okay, this is the valid scenario. This is an end-to-end journey that happens when somebody wants to transfer a fund from his account to the another account. So what is the alternate flow? This is the main flow. This is an happy flow that we call it as an happy flow. So what is an unhappy flow or an alternate flow? The insufficient balance. He's tried to transfer around $2,000, but he has only $1,500 in his account. Now the transaction is cancelled because telling that insufficient funds. Okay, he has he does not have a sufficient fund to complete the transactions. Second one is an invalid recipient account. He is trying to transfer an account to an account that the account does not exist, or the account number is wrong, or the SWIFT code is wrong, the branch location is wrong, or something like that. Okay, so something is wrong with the recipient account. Then he gets a message that invalid account. So these are the alternate flows. What is an exception flow? See, exception flows is some technical errors that happens, right? That is called as an exception flow. During the transactions, if the session times out, okay, so he loses and his internet connection stops working while he's transferring the fund. What happens? Then the session times out or a network error. User is redirected back to the login page in case of the internet is available. If the internet is not available, then it says that we are not able to reach to the particular page that you are requesting. Okay, that is a message that you are going to get. So this is basically a use case, and this will be basically given to you by the business analyst or the product owner. Your job is to basically design the test cases for this use case. Now let us see how to do that. From these use cases, you can basically directly derive the test cases based on the happy conditions and the alternate flows and the exceptional flows. Okay, so what I will do, I have created some test cases and I will try to present you the test cases. Okay, test cases 1, successful transfer between the valid account with the sufficient balance. Okay, transaction is successful, confirmation message is displayed. That means user has a valid balance and the recipient's account number, account details, everything is correct. Then the transaction becomes successful. It goes successful. Okay, it goes in a happy way. Second one, transfer fails due to an insufficient balance. Error message gives like insufficient fund. You're trying to transfer a money which is more than whatever you have in your account. Transfer fails due to an invalid recipient's account. Either his name is wrong, account is wrong, or the SWIFT code is wrong, things like that. Then you will get a message like invalid account. The fourth case is transfer interrupted due to the session timeout. Okay, it is trying. So if you keep your session long in a banking application because of security reasons, you cannot keep your session long, right? So if it is 5 minutes, if you're idle, then your session times out and you'll have to forcefully close it. Forcefully closes your application and you have to re-log in again. It redirected to the login page. The fifth case is transfer interrupted due to the network issues. The connection goes off, then the connection error displays the transaction is not processed. So using an use case, you can directly derive the test cases. This is called as an use case based test design technique. Some of the real world use cases where the use case based testings can be used is an e-commerce checkout process like add to cart, payment confirmation. This validates the different payment types, coupons, address errors, etc. Healthcare, patient appointment booking, handles overlapping slots, invalid doctor ID, successful booking, etc. Travel booking, flight reservation, for search, select, payment flow, alternate cases, that is the happy flow. The alternate cases here are like an invalid card, the unavailability of the seat, the flight is not available or a given timetable, etc. In the banking side, account statement generation, different date range, the empty results, access permissions. These are all the exceptions that we can think of. And in education, online exam submission, timeout handling, invalid question attempts, final submission confirmations, and all these are our test focuses basically. So you can think of, as an analogy, you can think of use case testing is like a storyboarding a movie. Here the main plot, the main flow tells you the normal story. The side plots or an alternate flows shows what happens if something goes wrong. As a tester, your job is to test every possible storylines, but without filming unnecessary duplicate scenes. That brings us to the end of the part 1 of test design technique session. I am going to cover the risk-based testing, which is also called as an RBT, and orthogonal array technique, which is called as an OAT, in the coming session. Hope you have enjoyed learning with me. If you find this video helpful, please like and subscribe to my channel. Thank you for watching.